Good evening, everyone, and welcome to this webinar. We have our very special guests, Anne and Jim from the American Printing House for the Blind, who will be delivering this webinar. And in this webinar, you'll learn about what Code Jumper is, as well as learn about the core curriculum that was developed by Robin Lowell, a very well-respected educator in the US. So I'll hand you over to Anne and Jim now. Thank you.
Thanks, Tony. Thanks so much. We're really excited to be here with you today to talk about Code Jumper and how we can build career paths through accessible coding. So I'm going to go ahead and get started with what is Code Jumper. So Code Jumper is a physical programming language developed to teach basic computer programming concepts to students ages 7 to 11. It's designed for students with visual impairments, but it's also meant to be very inclusive. So all students can use Code Jumper, regardless of their level of vision. So when we look at what's available today for students to learn beginning coding, there are many very good coding programs that are available for younger students as well. Microbit and Scratch are programs that you may have heard of. Now, unfortunately, they are not accessible for students with visual impairments. These apps work using block coding. They're done by dragging and dropping blocks of code to create a program that has a visual representation of the code. The blocks fit together in a specific way, sort of like a jigsaw puzzle. Now, this creates challenges for students with a visual impairment. The app may require the use of a mouse, for example, or the apps are very visual. Often code is created to move a character around on the screen, or it creates a visual, like a thermometer. Students can participate by giving input. They can make a suggestion for a command, but they will not have the experience of creating the code and then executing it. What we have to remember is that all students can learn to code if they're given the right tools to learn. What Code Jumper does is it takes the concepts of block coding off of the computer screen and it puts it on the table right in front of you. And this makes it accessible to all children. We want to talk a little bit about how Code Jumper got started. It began with a research project called Torino. In 2016, Cecily Morrison, a researcher at Microsoft Cambridge in the UK, decided to take on a special project for her son, who was born blind. She quickly realized that most of the programs that taught children about coding were not accessible or compatible with a screen reader, and this put her son at a disadvantage compared to his peers. So she set out to create a physical, tactile programming language that would be accessible not just to her son, but to all of his friends. Cecily and her team first imagined creating blocks on a table that looked like the blocks and the block coding on a screen. She worked with a young design team of 4 blind and low vision children. They learned that the blocks were not really a good idea. Blocks would get lined up and then they would get forgotten about. So they tried magnets, but magnets would fall apart when the children would try to pick up their program for a full 3D experience, a 3D dimensional experience. Now up on the screen right now, we're showing an illustration of the young design team's first design. And you see sort of some blocks and bead type things being strung together with some strings, and that's in sort of a drawing. Some of them look like bracelets, some of them look like beads that have been strung together. The young design team helped Microsoft craft these shapes that fit inside the hand. They guided the developers to pods from here, and these pods immediately produced a response, almost like potato-shaped pods. So instead of building blocks, the Torino project evolved to a concept that was centered around linking beads or pods. And that became Code Jumper as we know it now. One of the real advantages of taking block coding off the screen and making it physical, putting it on the table in front of you, is that children can be encouraged to physically touch, follow, or what you call tracing in the programming world, the program with their hand as it plays or executes. Now, this builds a better understanding of what code does, piece by piece. And this is a research-backed teaching technique that promotes learning and coding skills. Now, alongside learning basic programming tasks, CodeJumper is very well suited to teaching computational thinking because the programs are simple. They can never, ever get large and unwieldy. On the screen right now, you see on the left a picture of our building, the American Printing House building in Louisville, Kentucky, and our 300 plus staff standing out in front in our Welcome Everyone t-shirts. The American Printing House was selected by Microsoft to develop and distribute CodeJumper. We announced this partnership at the BEETT show, a technology show, an education technology show in the United Kingdom in January 2019. This past January, we returned to the United Kingdom for our CodeJumper launch. This event was attended by over 70 people, including students, teachers, coders, and others. Distribution has now begun in the United States, the United Kingdom, here in Australia, and in Canada, with our complete worldwide rollout planned by 2024. Humanware is our international distributor, and Vision Australia and other similar nonprofit organizations that serve individuals who are blind or visually impaired are also our partners. Now, these partnerships are very, very important. We all serve the same community, but we do so in different ways. Together, we're going to be able to spread the word about the importance of teaching students coding and computational thinking skills. This helps create new career paths for the students that we all serve. The story of CodeJumper has caught the world by storm. It has already helped us break down barriers and beliefs that blind children can't learn to code or that they can't grow up to be coders. And this way, CodeJumper is more than just a product or a classroom tool. CodeJumper is helping to create a revolution in how the world thinks about the potential of children. Since 2019, we have received media coverage from places like Fast Company, Tech Republic, TechNet, BBC, CNET, well over 2,000 media stories. There has been over 4,600 views of the blog that Microsoft posted about CodeJumper in January of 2019. The world is watching to see what happens next. Last January, CodeJumper received the Innovation Award at the Consumer Electronics Show in Las Vegas, CES. CES is the world's largest consumer technology show, and we were honored as one of only 31 of the world's top technology companies, along leaders in augmented reality, smart homes, self-driving cars, robotics, and artificial intelligence. So why is coding so important to children? Very simple, employment. Between 2016 and 2026, the number of computer science-related jobs are expected to grow by 24% worldwide. This is due to the Internet of Things, IoT, self-driving cars, artificial intelligence, virtual reality, and other emerging technologies. Despite all of these job market demands, fewer students are graduating with computer science degrees today than 10 years ago. This decline is even higher among women and minorities. Only 2.5% of all undergraduate degrees are in the field of computer science. And also, exposing all students to computer science principles will promote the field and better prepare our students for the jobs available to them when they graduate. Careers in coding help in many different ways. The STEM fields are the fastest growing career fields. Coding also teaches thinking skills that are critical for all careers. And we already know that our students are great problem solvers. Corporations and businesses want a diverse workforce because they get a diverse set of solutions and ideas, and their workers can empathize with their customers, who are diverse as well. And CodeJumper gets kids thinking about their dreams and what they can achieve. And if you don't believe me, just listen to this video and to Joshua and about his dreams.
Row, row, row your boat. Twinkle, twinkle, little star. Helen's story.
All different strands of code 9-year-old Joshua Lewis has pieced together using CodeJumper.
I have to loop around here.
By plugging together small pods, Joshua is learning the basics of computer coding. Something that is fun, but also puts him on a path to reach future goals.
I could probably maybe go on the internet one day and program games and create new games. And maybe program robots to do different things.
Joshua has some big dreams that can't happen without coding.
Maybe invent self-driving cars when I get a lot older. Some stuff I want to invent now.
Plug by plug and sound by sound,
We're gonna do a pause.
he's getting closer to his first big invention.
Half a beat.
CodeJumper is a physical computing language that is based on block coding, but it's been taken off the screen and put physically on the desk in front of students.
Robin Lowell, a TVI, developed the teaching curriculum that comes with CodeJumper.
Watching a student use CodeJumper for the first time is an amazing experience. So the kids, they just want to dig in from the second they lay hands on it, and you can see those little wheels turning in their mind and this problem solving and what ifs.
Robin says all students should have the opportunity to learn how to code.
There are so many other skills built into it, such as computational thinking, problem solving, and collaboration, that students need to learn these skills from an early age to not only have the skills to move forward to other text-based coding languages, but also understanding that this is something they can do from a young age.
Maybe we should try it?
Skills that all students can learn together.
This is a loop pod you see right there.
Every student in the class has the opportunity to fully participate in the experience that the teacher is providing.
Something Joshua's dad, Darren, is grateful for.
The ability to learn and to do things that other kids get to do it's a joy. It's a joy to watch his face light up when he plays with these things, and to have him talk about what he wants to do in the future is all amazing.
He knows that accessible innovations like CodeJumper will break down barriers for young people who are blind or visually impaired.
Joshua wants to be an inventor. He wants to invent flying cars one day, and the next day it may be a way for him as a visually impaired person to be able to fly an airplane.
And as long as tools like CodeJumper are available, Darren has no doubt Joshua can build his inventions.
Our hope is that he will be able to do whatever he puts his mind to do.
Visit codejumper.com to learn more.
So how does CodeJumper work? It is similar to block-style coding, like Scratch or Blockly or Microbit, but it's physical, it's tangible, and it's accessible rather than visual. CodeJumper teaches concepts with physical pods and audio feedback. The CodeJumper app comes with preloaded with a number of sound sets, including stories, songs, instruments, and other sounds. But teachers and students can also be encouraged to create and add their own sounds. Each sound set has up to 8 sounds that can be connected together. Why don't we go to a CodeJumper demo?
So today I'm with my colleague David Woodbridge, who is our AT National Advisor, and we're going to do a live demonstration of CodeJumper. So in the camera you'll see the CodeJumper kit, and David, if you'd like to go through what's in the kit for our audience, that would be great.
Indeed. So as you can probably see, we've got a lovely case that all the CodeJumper elements fit into, and that's actually an extremely sturdy case. So you've got the plastic outside, 2 clips to hold it shut, and then you've got the foam inserts that hold all the components of the CodeJumper kit. So the first thing that makes this whole thing talk and work, the first thing is the actual hub itself. And as you can see, that has got a speaker on it, 2 buttons to do basically play and stop, a volume control, and then on the front of it we have 4 ports going from left to right, which later on it'll make more sense, but they're basically called thread 1, 2, 3, and 4. And then underneath the hub you'll find that you've actually got a little compartment door that you need to unscrew a screw, and that's where you've got a couple of batteries to charge up the CodeJumper hub itself. Now, I mentioned that in particular because it's running on batteries, you can use it for a couple of sessions, but they always advise you then to change the batteries because otherwise you'll run out halfway through. So that's the hub. And then we have the really cool part of the CodeJumper kit, which is I love to play with, and that's the 8 Playpods. And by the way, for people that can't see this, all the pods in the kit are differently color coded. So Tony, what's the current color of the Playpod?
So the current color of the Playpod is blue.
Excellent. So the Playpod has got 2 knobs on it. One's like a donut shaped, and one's more of a crown shape that sticks up more. One's more serrated than the other one. So one knob is for the different sound, and then the one that's got a more serrated feeling on it, it's higher. that's for the duration of the sound, whether it's normal speed, 1.5 times speed, and so on. And we'll get to these when we plug it all in a minute. So you can select different sounds, and that's what I meant by different threads. When you plug one of these into the hub, you can have different themes or sounds going from different thread 1, 2, 3, and 4. So that's the Playpod with its little cable on one end that you would plug into the hub, and of course a port on the other end of it where you plug in another Playpod or another pod. So then we've got the pause pod, and I'm assuming from memory, Tony, that's a red one.
That's correct.
Okay, which is really funny because I already feel like saying it makes the code go faster, but it actually pauses the code when you plug all these pods together. So what that does is, if you can imagine, I'll explain this now. So the pause pod, you put them between, say, two play pods, and then when you change that setting on that knob to say pause for 1 beat, 2 beats, etc., of course that pauses the code between the two play pods talking. Then you have another pod which is called the loop pod. Now that has one knob in the middle, and then coming off to one side of it you've got a long cable and a short cable, and then on the other end you've got 2 ports, one on the side and one sort of down the bottom right hand edge. And color wise, Tony?
It's yellow.
Perfect. And to make that one, to use that one, this is called the loop pod. So what you can do is that top left-hand cable, you would plug that into, let's say, a Playpod. The short cable you would plug into, say, a Playpod. The other end of that you would then, say, plug back into via an extension cable, we'll talk in a minute, back into the loop pod, and then you can keep going with your code. And of course, that's to make the program at that place, the code, loop around how many times you would then turn that knob in the middle. And then we've got a selection pod, and this is my cool one because this has got two knobs on it that are, one has 2 spokes and one has 3 spokes on it. And color-wise, Tony?
They're green.
Okay, so what this one does, this is in programming terms the if-then statement. So let's say is if I'm playing the duck sound, and if the duck sound is greater than what I'm playing another sound, then go and do something with it. So it's like the if-then statement. And that's quite a powerful one, that one. So that's one of my favorite ones. Then we've got another pod, which is actually the final one in the series, and that's called the merge pod. And color-wise?
There are no dials or knobs, but it's green.
Yep. Excellent. And the merge pod sounds like what it sounds like. It merges the code into one stream. So let's say, for example, you've got 2 lots of sounds happening, but then you want to merge them back into one part of the program, and that's what the merge pod is for. So that's basically all the pods, and they of course link up together all via those cables, including that extension cable, to make it a bit easier for someone doing a loop. And then we've got the plugs, which you can plug into the top of each of those pods. And these variables can do different things. So we've got constant variables and we've got variables. So we've got things like a random counter. We've got an infinity counter, which actually sounds what it sounds like. It makes the code keep going to infinity. And by the way, you can stop it. It's got a counter pod for plus and minus for counting up and down, and so on. So they're sort of a little bit more advanced. So we tend to leave variables and constants and that sort of stuff, of course, when a student gets used to using it. So with the combination of the play pods, the constants and variables, the extension cable, and the hub, of course, that's how this whole thing comes together. Now, to make all that magic happen, we need to, yeah.
Before you go ahead, I just wanted to describe the color of the plugs.
Oh, good idea. Yep.
So
right.
There are 2 types of plugs, as David had, 2 colors of the plugs.
Mm-hmm.
One is purple, and on the top of the purple plug, there are dots or symbols on it to signify, I guess, the number of the constant or the symbol that it's supposed to do. And then you also have a gray plug, which is a bit longer.
So when you make this thing work together, so at the moment, if you plugged everything into that hub, it's not actually going to do anything. You need to then to Bluetooth connect that hub to your Windows computer, and then on your Windows computer, you run a program that you've downloaded off the Windows Store, and that's called the Code Jumper app.
David, I'm just going to share my screen so the audience can see what the program looks like.
Excellent.
So on the screen, I have the app. And just to describe it to the audience, at the top, I have like a menu bar where I have the first menu option is Bluetooth. So that allows you to connect the hub to the actual computer itself. Then you have the sound button, about button, play button, read button, and stop button. And underneath the menu bar, you have your different threads. So that's what the ports on the hub that it refers to, as David was explaining before.
Exactly, that's right. So thread 1 to thread 4, going from left to right on the physical hub. So let's see if this is going to work magically. So if you turn the hub on, Tony.
I've done that already.
Oh, okay, good. All right, so let's take one of those pods, the Playpod, and let's plug it into thread 1 on the hub itself. Okay, now the first thing I normally do is to make sure it's working. So Tony, if you want to press the left-hand button on the front of the hub itself to play the code.
Twinkle.
Beautiful. Okay. So what happens with each of these Playpods in particular, we can actually choose a different sound. So Tony, if you want to turn the flatter knob on the Playpod, we should be able to hear all the different sounds on this particular Playpod.
Little star. Twinkle.
There we go. All right. So as you can probably guess, if this Twinkle Twinkle one is, we're going to have to write a code. Well, we want to write a code that sings Twinkle Twinkle Little Star. And of course, you have to get them into the right tone and that sort of stuff. Now, to change the tone of that sound or the duration, that's the duration knob, which is the higher knob on the Playpod. So Tony, if you turn that speed or duration knob.
Twinkle, twinkle.
Okay, cool. All right. So, and then here's a bit of a trick at the moment, because one of the things we'd like about coding is to always play your code. So let's just remind ourselves where we are. So if you want to press the play pod again, Tony, just the play button on the play pod. Okay. All right, so that's our first line of code. So we need to do now the second line of Twinkle Twinkle, i.e. the second line of our code. So if we plug the second play pod in now. Okay, now the good thing about the code jumper, you'll always get that click sound via Bluetooth to let you know you plug the second play pod in. All right, so let's play our code now. So if we press the play button again.
Twinkle, twinkle.
Okay, so as we can tell, our second line of code is not correct. Now, before we move on to correcting that, there is a way that you can actually physically have the hub say each line of the code. So if you press the play and stop buttons together, Tony, at the same time, that will read out our code to us.
Thread 1, twinkle, twinkle. Play Twinkle 2 for 1 times speed. Play Twinkle 2 for 1.5 times speed. In thread.
That's fantastic. So in coding terms, we know that line 2, which was play Twinkle Twinkle 2 at 1.4 times speed, is actually incorrect, because normally when you sing Twinkle Twinkle Star, the first Twinkle Twinkle is exactly the same. So we need to change the speed on the second play pod. So Tony, let's try and turn it counterclockwise and see what happens.
Twinkle.
Okay, and let's play our code by pressing the play button.
Twinkle, twinkle.
Beautiful. All right. Now we want little star, or just little for this example. So let's plug in a third play pod. and we heard the click. Now we've got to choose a different sound. So we want little to be pronounced now. So if you turn the sound knob on that third dial, Tony, till we hear little. Okay, so let's play a code and see what happens. So press the play button.
Twinkle, twinkle.
I don't think that's quite right. I think we've got the frequency a bit too high. So what we need to do, we now need to change that frequency. Now, if we wanted to do this, and we won't do it now, but if we wanted to check what frequency that's running at, we would now press the play and pause buttons together and we would read out line 1, line 2, line 3. But that's pretty obvious. That's playing way, way too fast in the duration. So let's turn the speed or duration dial counterclockwise. Okay. Okay, now let's play our code and see what that sounds like. So play, just press play and we'll see what the code sounds like.
Twinkle, twinkle, little.
That's it. And let's finish off by saying star. So plug in the fourth Playpod. And let's see what that fourth Playpod's doing. So we want it to say star. So if you turn the sound knob, Tony, to where it says star.
Twinkle, twinkle, star.
Beautiful. And let's play the code since we've got 4 lines of it so far. So play and stop together to play the code.
Thread 1, twinkle, twinkle. Play twinkle 2 for 1 times speed. Play twinkle 2 for 1 times speed. Play a little for 1 times speed. Play star for 1 times speed.
Ah, hang on. I think we've made a bit of a boo-boo in our code. We've got little playing at 1 times speed. So if we come back to the third play pod, Tony, and rotate it clockwise.
We've got the speed right, David.
Did we?
Yes, I think the first play pod, we don't have the first twinkle.
Oh, okay. Never mind. We'll keep going anyway. We're not having an exam. All right. So let's just play. I think what we need to do is decrease the star one, don't we?
Yep. So I'll do that now.
Yep.
Twinkle.
Done.
All right. Let's play our code. So press play.
Twinkle, twinkle, little star.
Oh, beautiful. There you go. You were right, Tony. I'm glad someone's listening. So as you can tell, you can actually have really fun. Now, we haven't had to interact with the Code Jumper app at all on the screen. What we normally suggest, particularly for young children, is that you can completely do it via just using the hub. So like I said, you'll hear when you plug in each pod, you'll hear a physical click. If you don't hear a click, you haven't plugged it in properly. You can play the whole code. You can stop the code at any time if it's a long code sequence, because at the moment we've got 4 in there. You can imagine if you've got 8 in there and so on. And you can also press the 2 buttons at the same time to have the Code Jumper app actually read out each of the lines of code. And then visually on the screen, we could also access the play button, the stop button, the sounds button, and we could also access each one of the lines of code underneath thread 1. And that would tell us also what each line of code was if we were using the screen reader on the computer, such as NVDA, JAWS, or Narrator. And also the same with large print, and of course also using a refreshable braille display. So that's pretty much the Code Jumper example in a nutshell. And of course, if we stuck in a pause pod, which really wouldn't make much sense in Twinkle Twinkle, but if, for example, you were playing with the jungle theme, you might want to put a pause pod in between the 2 play pods so that when you hear the frog do his little froggy sound and then him splashing into a pond, you might want to have a pause. So you hear the frog, pause, and then a big splash as the frog splashes into the pond. So that's the Code Jumper app, hub, and pods, extension cable, and variables in a nutshell for you.
Thank you so much for your help, David. So this concludes our live basic demonstration of CodeJumper. If you'd like more information, please contact Vision Australia.
Thanks for that great demo. Now, I know one of the most common questions we get when we present on CodeJumper is, do you have to know coding to teach CodeJumper? And the answer is absolutely not. You don't need to know any coding to teach kids CodeJumper. One of the biggest values that CodeJumper brings to your classroom is the curriculum that was created to help support it. Each lesson has step-by-step instructions, key vocabulary words are defined, and the links are provided to outside resources. CodeJumper's curriculum plays to the strengths of you as a teacher. It's creative and fun. The CodeJumper curriculum is divided into primary and advanced lessons. The primary lessons include fundamentals such as computer systems, introductions to sequences and algorithms, learning parameters, threads, and basic debugging. For older or more advanced students, you can also progress to our advanced lessons and learn about constants, selections and randoms, variables, nested loops, topologies, and even concepts such as network protocols, binary numbers, and Boolean logic. It sounds like a lot for your classroom, but the CodeJumper curriculum really makes it easy to teach and for the students to learn. Each lesson is structured into an unplugged activity where students can learn coding concepts without the use of CodeJumper or a computer, a guided activity where students walk through concepts together using the CodeJumper kit. Typically, these activities are more basic and they help students understand the concepts involved. Then there's an exploration activity where students are working together in groups or independently to create programs and complete tasks. And then finally, there's a check for understanding. At the end of each lesson, you can use this check for understanding to help ensure that students have grasped the concept. Lesson structures are broken down into expected outcomes, key vocabulary, such as the vocabulary words used within each lesson, the resources, which include videos and outside resources that'll be needed for the lesson in the classroom, and the objectives, such as what the students will learn during the activity, materials and the outside materials that may be needed for the activity. Printed materials are all found at the end of each lesson. The instruction, or step-by-step instructions for each activity, these can be used as is, but also provide some suggestions on where to modify to meet the specific needs of your classroom. And then finally, closure, so strategies on how to close out the lesson with your student. Each lesson also has an unplugged activity, and teachers can use or modify these to fit the needs of your classroom and benefit in the opportunity to learn abstract coding concepts in a concrete and tangible way. The guided activities are when students have the first experience learning the concepts using the CodeJumper kit. Instructions for the guided activity include step-by-step demonstration programs for teachers to create, including language to use and explain the concepts. These activities also provide hands-on opportunities for students to create lessons or create programs related to the topic of the lesson. So now it's time for your questions. Once again, the user guide that comes with CodeJumper contains a curriculum with 19 lessons, assessments, and tutorial videos, and those are all available for you at codejumper.com/resources. And there's also a 1-hour course available on the Microsoft Educator community. Thank you, and for more information, please visit codejumper.com.